Okay, so welcome back everybody from the BOFs, and now we're sort of rolling into the final session of the workshop. And before we turn the final session over to Jen and Larry, Matt and I wanted to just give a sort of a quick readout about what happened in each of the BOFs. You want to go first, Matt?
Yeah, sure. So our BOF was on coming up with a set of resources for teaching online networking. We first talked about how we can even form a community around this and encourage people to participate. One idea that was brought up was to look at how IETF does this. They have this procedure of kind of creating BOFs, and those evolve into working groups. And so that might be something we could look at. Another observation is that we should make the barriers to entry really low, since there's kind of low incentives sometimes in our field to kind of participate in things like this. We should make it very easy to share resources and also share experiences. We thought one way to increase incentives for people to participate would be to, at our respective institutions, encourage development of teaching tracks, because there's lectures, there's also teaching professors, and kind of creating tracks for tenure and also jobs that are kind of focused around teaching may help. We also talked about what we would want out of a resource sharing site. If we had a site where we could actually share resources with one another. We thought a few important things include capture not just a set of resources and descriptions, but also have some way of capturing people's experiences with those resources. Did you use it recently? What kind of students did it work best for? And so on. We thought curation was important, but curation should not be done too heavily. It could be something where we kind of mark resources as working or not working. Ideas about like what schools it might work best for, but we shouldn't necessarily delete resources because maybe they're not working now, but they might be fixed later. We also thought it was important to think about how resources are used. We thought one possible workflow might be you go to the site, you do a search for TCP lab exercises, and you get you can see how they're ranked, where they're used. We thought it was important to look at how other sites do this. For example, Stack Overflow and Stack Exchange sites have some functionality that might be useful to look at for people review and things like that. We thought it was important to have some sort of moderation because just anonymous commenting can be subject to spam and abuse. So we thought moderators could participate, but maybe moderation could be kind of light, something where we kind of just review for spam in topicality, but everything else could be posted. Another question we talked about is what sort of resources do we need that are not already out there? And it sounds like there's a number of things, but one thing we talked about in particular was repositories of exams and quiz questions. I think this is something that we hadn't hit on yet. And also repositories of engagement questions, because we talked about how when we teach, we sometimes throw out questions to the audience to kind of get them think, how many access points do you think there are in this building and why? And, kind of more high level questions. Having repositories of interesting questions like that might be useful. And also, we need help with doing online exams. So if there could be better platforms created for that, that would help. A few other things that were brought up. When we work together on resources, it would be nice to have some sort of mechanism to avoid redundancy, avoid multiple groups starting doing the same thing, or even just being unaware of resources that are out there. Do we need yet another set of videos? It's to have some sort of location maybe to look for that sort of thing, or some sort of structure to coordinate across universities in developing materials. There are these ideas about like how you do exams. One suggestion is that when you kind of introduce people to your class, you can kind of create introduction sites, kind of introduce people. One last idea that was brought up is that we should have a category of resources that are games, because it's important to kind of break the ice and things like that. One idea that was brought up in particular is to play Pictionary with your class, where students can kind of draw networking concepts, like draw congestion control. That can be, or other concepts you cover. That can be kind of a fun way to help learn the concepts. That's what we covered.
Okay, I'll report out from the other BOFs. So of course we didn't pay any attention to the rules, I guess is the first for starters. I don't think I didn't see anybody edit the document. Maybe people were taking notes, so we just really had a free-flowing discussion. I'll tell you the topics that came up. There was a discussion about what the mix of synchronous and asynchronous, how many people were pre-recording versus just doing things live. It seemed like almost everybody, there may be 20 plus people in there, was going to be a mix of pre-recorded, asynchronous, and then synchronous classroom. We talked about not overloading students with work, especially if you're pre-recording things, to remember that, I don't know, the time one spends in class is not necessarily, now we can dive into more deeper material, but to think about how much you want to cover and, again, not overload students. There was a lot of discussion about the roles of TAs and at both the graduate level and maybe undergraduate graders and undergraduates helping each other. We talked about, rather than just saying what worked out, what didn't work out, what did you try? And then there was a discussion again about cheating, the honor codes, and the surveillance state, I guess one might say. One thing that, the way I closed out our BOF was to remind people that everything in the main sessions is being recorded, the BOFs are not, and those Google Docs are meant to be working documents and sort of history going forward. And those are the kinds of things that people will be looking at next week and a month from now and a year from now. And so I'd encourage everybody here, everybody has right access to both of the Google Docs, to take a look and contribute, because that kind of synthesis is really, again, what people will see a month or a year from now. And so they're really, really important. As great as the conversations and as stimulating as the conversations that we have, those synthesis documents, I think, are going to be critical. So please contribute. Okay, so I think with that, we're going to hand the session over to Jen Rexford and Larry Peterson, who are the co-chairs for this final bigger picture looking forward session. Jen and Larry will run this for an hour, and then maybe Matt and I will wrap up for 5 minutes at the end, and we'll pretty much wrap things up on time. So let me turn it over to you.
Great. Can everyone see my screen?
Yes.
Great. Great. I'm Jen Rexford. I'm delighted to be here with Larry Peterson moderating the last session, where we're going to take a look at the big picture and chart a path forward. The 4 white papers in this session asked broad questions about how we should teach computer networking in the future, both in the coming semester of mostly virtual instruction and longer term, whether virtual or not. Some of the authors argue that online education has advantages for reaching more students or even offering new ways to study the internet itself. Other papers looked at how networking textbooks and lectures might change, including what topics we should cover and what we should actually cover less of as the field continues to grow. So we'll start with a brief overview of the panelists, and then they'll each speak for 3 to 5 minutes, and then Larry's gonna launch us into a discussion. So we have 5 amazing panelists. 3 of them are authors of white papers in the session, and Larry wrote the other white paper that was presented yesterday. So Edmundo is gonna talk about how to promote student interactivity and engagement, how to share resources, and also how to measure how you're doing in teaching, particularly when you're teaching online. Then Tom is going to talk about the broader problem of educational access that will persist even when instruction moves back to being in person. Jim is going to talk about the idea that teaching at a distance may be here to stay, even when the COVID epidemic is behind us. And he'll look at the drivers for why that's happening and what it means for our departments, our faculty, and our universities more broadly. Keith is going to discuss a white paper on what belongs in an introductory networking class, and in particular, what we could take out to be able to make room for new material. And then finally, Ross is going to talk about a user-centric approach to teaching, where we leverage students' remote local environments to measure and understand the internet. And so I'll let Edmundo take it away.
Thank you very much. Can I share my screen? I'm not.
You should be able to now.
Okay. Okay, try it again. 1 second. Can you see it?
Yep.
Okay. So good afternoon or good morning or good night for everyone. I just mentioned a few topics, and in fact, some of them have been repeated a few times over this workshop. So these are some talks that Jim and I have been discussing about as well. So my slides are full, but just when I think it would be nice to bring to the document. But how do you promote student interactivity engagement for asynchronous and live classes? My thought is that you should engage students both in the process of lecture preparation, and in fact we had a very nice experience with that 15 years ago when we started preparing lectures or asynchronous lecture for a computer science class for the interior of the country, and that worked pretty well. The students, we had fellowship for students, they engaged with the faculty, and it helped a lot. Both of them liked a lot the experience to work together. And recently, also during live classes, promote student interactions, I say electing a few people in class, role models in class, even after one or two classes, you are able to select the students and try to help you and say, you're gonna help me ask questions for me if people are silent. So we are gonna do something in the chat and help me. That has been working pretty much. And in fact, in the experience we had for this distance learning class over many years, it has been reported for many students that working together, it's very nice. Being in a community or part of a community is very nice. So collaboration, collaboration, collaboration. And finally, in the slides, we experiment also with for asynchronous lectures, so slides that are programmable, that the students have to interact. So you can do that, and the students like it. Some interaction with the slide and the faculty asking questions to the slide. So that's another thing that can do. Anyway, the second thing for looking ahead is share education resource. That's been said over and over here, but in an organized way. We can share explanations of topics. So in fact, we do that in live classes. When a student asks a question, never thought of something, and then you have to come up with a different explanation. But as a community, why can't we all share different explanations? You can, of a topic, we can record some explanation and do that in an organized way. So again, we collectively create a set of lectures for a given topic and share that in some place and share experience globally. And I'd say that it's nice to give a fellowship to the student. So finally, measurements to learn. Collect measurement to keep track of how students interact with the material, and mostly to get feedback for lectures. So you promote lectures either for asynchronous video lectures and to understand how the students learn the material, and try to correlate the interaction with the learning material, quality of online material, etc., with success rate. So that's also a very good feedback for faculty when they record some lecture. Online assessment, exams to scale, that's a hard question. So we all talked about automated question generation software and things like that. But as a community, you can do much more than what we do individually. And automated translation and caption, if you're going to reach a broader audience, and I'm talking helping countries, not in a paid stuff, or totally free material, and design resources that scale. We heard yesterday that how difficult in some areas is to students to have access to live streaming, etc. So design resource that can scale to the amount of bandwidth. So collaboration is the key thing. Share resource, share experience globally. That's my final thought. Thank you.
Great, Tom's next.
Sorry, let me figure this out. think this should work now. I could go here. Hopefully that works. Okay, so I'm going to argue here for a few minutes about thinking we should think larger, like much larger. Okay, so let's assume we're a year from now and the pandemic is hopefully under control. And what we will have then is a whole lot of faculty who spent the last year teaching remotely or hybrid or whatever. And there'll be this huge impulse for us all to kind of put this aside, forget that it ever happened. And now the question is going to be, you know, is that the right thing to do? Or is there something more strategic we can do for moving on beyond where we are for what we'll do over the next year? So the first part of this is, of course, that the economy is likely to be in a huge recession globally, but also in the U.S. Estimates for the economic loss for the coronavirus in the U.S. alone is somewhere in the order of $15 to $20 trillion. And even with that, the CS industry is likely to be supply constrained. That is, we're likely to be the case of the CS industry will want to hire a lot more engineers than are actually available to be hired. Okay, so if we then look backward, you could think, well, going back to where we were, if that's, you know, we'll just go back to how things used to be. That wasn't so great, or at least it was good, but only good for some students. And so my main thing is this question about equity, which is the state of U.S. college education is, you know, maybe the envy of the world for some students, but not so great for everyone else. The income and racial disparity in elite colleges pretty much mirrors the geographic and K through 12 education system in the U.S., which is great education for people who are well off, not so great for everyone else. Not wealthy colleges educate the children of the wealthy, non-research schools serve everyone else. And even with all of that, we have this massive underproduction of CS degrees. And that's even with CS faculty teaching enormous numbers of classes. That is, we're not going to solve this problem simply by hiring a lot more CS faculty. They just aren't CS faculty to hire. So just taking an example of like equity, I don't think this is UW Seattle because I have the numbers for UW Seattle, but I think just broadly this would be true if I looked at any state school that had a high research reputation. So the median family income for the University of Washington, Seattle is over $110,000 a year. We are not teaching average students. We're teaching primarily students who are in the upper 20%. And that number is even higher for computer science. So there are roughly 36,000 public school 10th graders in Washington State on free and reduced lunch. That's about 43% of the total number of public school students in Washington State. Out of that set, we graduated about 0.1% with CS degrees from UW Seattle, and the ratio is even worse for underrepresented minorities. This is not because those students don't want to learn computer science. We have a campus that's 35 miles away from UW Seattle, and relative to the size of the school, it's doing much, much better than UW Seattle is, in part because it's the place where students can just go study. It's not an elite school. You don't have to have really great grades to go. It's kind of in your neighborhood. They graduate about 5 times as many low and middle income students with computer science degrees as UW Seattle does, relative to the size of the school, about 7 times as many underrepresented minorities. Okay, so what's to be done? You could argue that the real problem here, as we've kind of seen over the last several months within the United States at least, is that we need to take this kind of new reckoning on whether we're really doing a good job for running our society for equity. And so you can think, okay, research intensive schools should take more low and middle income students, should take more underrepresented minorities. And one of the things that the education evidence is that if you do that, then those students will, over the long term, do as well as the other students, sometimes even better. There's a nice study from Texas that showed this. If you do admit students, then they will actually do well. They may not do well initially, but they will do it well over time. Except it's really unlikely that the research universities will actually admit substantially more low-income students. And even if they did, it really wouldn't solve the supply constraint that industry has. That is, we're just in aggregate really too small. So, so basically the argument here is we will all be experts at teaching remotely. So maybe we should think about starting a new college, the one that would offer online education to any student in the country, open to any undergraduate that has a good GPA, essentially modeled after the Georgia Tech program, but for undergraduates, either on a full-time or a course-by-course basis. And roughly the economic argument for why we should do this is within the US economy today, basically every CS degree that we add adds on the order of about $1 million to the economy. And costs, you know, somewhere in the order of $5,000 to $10,000. Okay, that's all I was going to say. Oh, I should stop sharing.
Great, thanks. Next up is Jim.
Great. That was great. I almost want to just talk about what you just said, but I have a few things I wanted to say, and I'll keep this pretty quick, actually. Let's see if I can find my PowerPoint slides. Go. Can you see that slide okay?
Looks good.
Okay. So I'm going to be pretty brief. I just had a couple of sort of almost closing comments that I wanted to share with folks. And Junaid yesterday presented this continuum that I really liked a lot, from face-to-face all the way to 100% virtual. And I guess I'd make the argument that with COVID, what we did was we went from what we've always been doing for 100 years, or 30 or 40 or 10 or 5 years, from teaching face-to-face to teaching 100% virtual. And one thing we might want to ask ourselves is what happens afterwards, right? Are we going to go back, as Tom was just mentioning, post-COVID, are we just going to go back and do what we were doing before COVID? And what I wanted to talk about is a little less grand than what Tom was just talking about, but I think that where we're headed is the following. You may think that LTE stands for 4G, cellular access, but actually it's a long-term evolution of teaching and teaching at a distance. And so I want to argue that I think more and more we're going to be seeing more of our on-campus students actually going off-campus for internships, for international opportunities, for work, or for personal reasons. They just can't make campus. So I think longer term, the equilibrium point is probably going to be, it's going to move away from face and the hybrid, and maybe in some cases 100% online. And of course, as Tom just mentioned, lifelong learning for what's done at Georgia Tech and with certificate programs that many of our departments are doing. If you look at the rise of Western Governors University, Southern New Hampshire University, you can see that the ability to access and get education at a distance is becoming increasingly important. So I want to make the argument, and this was the title of the white paper that Serge Fedida and I wrote, was, teaching at a distance, here to stay, or deja vu all over again. So that's a Yogi Berra catch New York Mets back in the 1960s. It's deja vu all over again. Well, we think teaching at a distance is here to stay, and that's what our white paper is about. And the last, just want to sort of on where we stand now in sort of moving from lecture-oriented material to active learning. I think we're really access point now, and I think a lot of that's been driven actually by COVID, right? Because throughout this workshop, we've heard about people thinking about, well, when I lecture, what's the value of the lecturing, and what does it mean to have students in a classroom? Should I just get there and lecture? I mean, I've always thought the easiest thing for me to do in terms of the least amount of time and effort is stand up and, teach and walk out of the classroom, and I'm done after lecturing. And if we want to really move to active learning, it's gonna, I'll get to that in a second, I think it's gonna be a lot more work. There are high quality online resources, textbooks, video lectures. We've talked about that in a number of sessions already. So the ability to think about changing pedagogy from just standing up in front of a group of students and lecturing and asking for questions and trying to be interactive to something more active, now's the time, right? And so I think the challenges that I've heard reflected throughout the discussion here is how important it is to think about the classroom as a community. And maybe if we move to this high flex hybrid, that some of our students are going to be at a distance, some of them will be there in person, but that what the classroom is all about and what teaching is all about is taking the students that you have at that time, creating a community amongst them, and they're not all physically going to be there. And so, how do we engage students both in the classroom and at a distance through active learning? And we've seen some really phenomenal work there that people in our community are starting to do. And then for me, if I think about the fact, I remember in the talk or the white paper that we wrote, I heard a talk by Jeffrey Ullman, who's a very famous computer scientist back in the 1990s, late 1990s. He gave a talk about how the internet was going to change education. And I believed it then, and then it didn't happen, and it didn't happen, and it didn't happen, and it didn't happen. And COVID has changed that, right? And now I do believe that we're thinking about really what does it mean to have a class and to have a classroom. And when we have all this high quality online resources like video lectures and textbooks, a class is really all about contextualizing and personalizing the material to the students who are in the class. And I think with that, that's really all I wanted to say. I think we're at this really special nexus point in time. I think we were pushed there a bit by COVID, but I think the technology and it's just part of the LTE, the long-term evolution of how we're teaching. So with that, I'm going to stop, and I look forward to the discussion. And
great, wonderful. So Keith, you're next.
Thank you. Let me share my screen here. All right, I hope you can all see that.
Looks good.
Great. So I just want to talk about a few kind of questions. So Nick McEwen and I teach an undergraduate networking class at Stanford, and it's based on a class that was developed originally by Nick and Phil Levis and David Mazières and others. And we have been sort of slowly refactoring, redesigning the class. And I want to talk about kind of three tussles, three kind of debates that we have, three struggles that we have that maybe the group also has would like to talk about, because I don't know that the answers to these are as obvious as I had thought. So the first kind of question, what belongs in our first networking class? The first is sort of this question about, sort of purity versus practicality, or, conceptual learning versus this class helps you get a job. So, in the older versions of this class, we really emphasized sort of, classical learning. We would drill students. We would ask them to do homework questions, a lot of questions. What happens after n rounds of the Reno AIMD algorithm on a link with these characteristics? What happens after n rounds of the distributed shortest path algorithm in OSPF? We want you to learn the taxonomy of network address translators. What is a cone NAT and a restrictive NAT and a symmetric NAT, these kinds of things. We really sort of drilled students with that kind of, nuts and bolts stuff that they talk about. I mean, especially at Stanford, most of our students go to work in Silicon Valley, and this kind of knowledge, is what they and their coworkers talk about. It's was very appreciated. And we try to sort of switch the class more into a conceptual direction. We say, look, there are ideas that recur consistently throughout the problem domain of networking. Ideas like reliability and queuing and encapsulation and abstraction and the principles of packet switching and the different kinds of states, soft and hard and caching and all the techniques for maintaining invariance in distributed systems. And so we want to teach you these fundamental principles and how many of the sort of things that we revere might actually be artifactual or might be consequences of these more the deeper magic, like the 7-layer model or the TCP state machine or the 3-way handshake or AIMD. These things, you need to know them, but they're not fundamental. This class is about the fundamental concepts. And I would say, we had mixed success with this. in the first class of networking, it's not clear that this is the right way to teach networking. It may be that the sort of drills and let's learn the 7-layer model, let's nail it, let's learn the state machine, let's learn what happens after n rounds of the distributed Dijkstra's algorithm. Maybe there's definitely benefits, I think, to both here. The second sort of tussle that we deal with is this, sort of breadth versus depth, or, are we teaching you networking or really kind of teaching you how to program? So we, in the breadth versus depth, we have a 10-week quarter at Stanford. So we have we have to be judicious in what we include. And so we have discussions like, should we talk about security? Should our students know about certificates and symmetric versus asymmetric encryption and how TLS works? Is this something everybody should know, or is this something where you can say, we just don't have the time to discuss that properly, so you should take the networking class? To what degree do we talk about issues specific to wireless networking? Do we talk about the physical layer? Do we talk about Shannon's theorems? How deep do we cover congestion control? We talk about Reno and Neurino, these kinds of things. Do we talk about RIP and OSPF and the distributed routing algorithms? So the question of sort of breadth versus depth is one thing. In the laboratory assignments, we had a set of older labs that had sort of grown up for a decade that were in C, and they were well admired by the students. And they were things like implement TCP, implement an IP router, and a pretty full one, an IP router that answers pings to its network interfaces and sends appropriate ISMP errors if the network is unreachable, and if it ARPs and it can't get a reply, send a host unreachable. And then also implement a network address translator in C. So these were pretty substantial, very substantial programming assignments, and the students really liked them. And when you would talk to the students, you'd say, what do you really like about these? They'd say, well, I'm learning so much about seg faults and how to fix them and debugging and the mechanics of C. And this class is a great way to prepare myself to take operating systems next quarter, because this is kind of like the class where you learn C. And I'm thinking like, well, okay, but we're trying to be teaching you networking here. It's not my job to teach you how to debug seg faults. So, in our newer labs, we try to be very pure. We encourage the students to write in, they're in C++, but they're in very austere C++, where, we never use pointers. We never use malloc. We never use new. It's very sort of modern. And they're very modular and require all kinds of careful structure and correctness. We say, if you're thinking about implementing an IP router, the forwarding logic of an IP router, you should not be thinking about ARP. Don't say the word ARP, because these are separate magisteria with separate concepts. But I don't know that the answers here are so obvious either. What counts as a distraction from networking? If you sort of insulate students from all the bumps that they can have, seg faults are real. Are we really serving students well? I think there's another kind of tussle. Should we make the students define the format for an IP datagram and write the code to parse it and validate the checksum? I don't know. Should we make the students write regression tests? The third sort of tussle I want to talk about is this question of sort of synchronous versus asynchronous. And when you give an assignment, is that a specification, or is that kind of an invitation for a conversation, invitation for inquiry? I think these are kind of linked. The students really seem to prefer the specification model, where we give an assignment and it is a spec. It is like something you could post on Upwork and expect some freelancer to implement without further questions. And they go off asynchronously and they do it, and they turn it in, and it's all great. And we kind of shifted to a mode where, we really wanted synchronous lab sessions. This was not maybe a well-timed switch that we did last year. We said, look, there's going to be a 3-hour block once a week. You show up. That is the laboratory. Imagine you're taking a chemistry class or an undergrad physics lab. You're going to show up. You're going to do the lab. And we will be here to coach you. And so the document we're giving you, please don't call it a specification. It's not. It's more like what you get from a customer. This is like, what do they want? And you're going to have questions. You're going to say, well, this isn't really clear. It's sort of ambiguous. Do you want this or this? And we want you to ask us those questions, because the document we're giving you is kind of an invitation for that. And some students like that, and some students really don't. Some students don't like showing up for 3 hours on a Tuesday evening. And some students don't like the idea that it's not all in the document. They really want to get a spec. And I say things like, well, is that what we're training you to do? Do you want to be some outsourced programmer who just implements the specs, making $4 an hour on Upwork, or we're teaching you to be an engineer? But I'm not sure the answer to this one is so obvious either. And the fourth sort of very practical tussle on our end there is, do you want to have open assignments? Because I put a ton of effort into these assignments, and I posted them on GitHub, and they were public for everyone. And then a student at another university came along and just did all my labs and posted the solutions online, pretty darn good solutions. And, I wrote to them, I was like, hey, we'd like to avoid a temptation for our students to cheat. Your solutions are very easily Googleable to our class, and it's kind of it's just going to create a temptation for our students when the solutions are so easily findable on the internet. You know, like you forked my GitHub repository, and they decline my very polite request to take them down because they say, hey, I'm trying to get a job here, and you know, these solutions are going to help me because they're part of my public portfolio. So I'll end there, but I think these are sort of 4 issues where I certainly don't have the answers, and I think, you know, I'd be curious to hear other people's thoughts, and I think this is kind of where my thinking is now on what should be in our class, which is starting in a month.
Wonderful, thanks, Keith. And finally, Ross.
Can you hear me?
Yep, we hear you, but we don't see your slides.
That seems important. How about that?
Looks good.
Cool. Can you see me? There we go. Excellent.
We lost your slides in the meantime. Oh, they're at the back.
Cool. Okay, so hello everyone. I will be presenting user-centric networking, a new approach to designing a networking curriculum with my advisor, Jen. My name is Ross Teixeira, and a couple notes about me. To my students, I am not the Ross in Kurose and Ross. And to you all, unfortunately, there is now more than one R Teixeira in the community, so I apologize for any confusion that might cause. So in thinking about how to design a new networking curriculum, we started out with a few basic questions. First of all, we want to make networking really personal and really engaging for students. This is a question that's come up a lot in this discussion so far, and how do you make a course engaging and personal? And 2 ways that we settled on were, well, we want students to be able to conduct measurements from their own locales, understanding how the internet works in the real world and understanding what tools they can use to measure it and learn about it. And we also want students to discuss internet events, both, you know, historical events, things that have happened in the real world that have affected the internet, and also public policy issues surrounding the internet, and giving students an idea of and an understanding of how they fit in this bigger picture and how they might be able to shape the internet. And we also talked about, you know, what are the advantages of remote learning? You know, we talked a lot about the issues where it's hard to engage students and students are across many different time zones. But at the same time, the fact that we now have many students at home with diverse vantage points at many different locations that are all using this common internet, this actually prevents an interesting perspective and a lens to view the internet and conduct measurements from the student perspective to learn something about the internet. So our goal for this curriculum is basically to take active learning to the max. We want to give students as much opportunity to engage with the internet itself by conducting measurements and from their own locales, and also engaging with discussions on public policy and historical events with the internet. And also these measurements across students can then be combined together to produce some class-wide statistics or this bigger picture about the internet that can then be shared with the class. And so if there's one thing you take away from this approach, what we really want students to do is, well, we want to not only empower students to understand their place in a worldwide network, but also to understand their role in shaping the internet in the future and what power they have for that. So our design is first motivated by, we want students to measure the internet as much as possible. So a lot of times networking curriculum is designed either top down or bottom up. You start at application level and you sort of work your way down to understand how the nuts and bolts work, or you start at the bottom up, the fundamentals of, you know, how does local transport work, Ethernet, and building up routing and reliable transport up to the top. But when students are conducting and reasoning about internet measurements, they're sort of naturally engaging every level of the stack. You know, if you want students to measure the performance of an application they're looking at, for example, just browsing the web or watching videos, that can be affected at every level of the stack. Performance might be affected by, you know, the video compression algorithms that are being used, or the amount of concurrency in their browser. Comes down to whether they're using reliable or unreliable transport. And then of course there's issues in global routing, what paths they take, what congestion they experience. And so in order to design a curriculum around student measurements, we decided that we would introduce layering sort of fundamentally early on and get that out of the way, and then allow the curriculum to be driven by a user-centric perspective, where we start at the student's local network and just sort of having them understand, how they connect to the internet, the bootstrapping process, what other devices might be on their network, and then sort of spreading outward across all layers as students get broader and broader, where they start to understand now, well, what are the popular applications that are used on the internet and how do they work? Things like web browsing, video streaming, teleconferencing, which is of course very apt at the moment, and also introducing students to peer-to-peer networks with torrenting or chats like the Matrix protocol. And then moving more broadly out to understanding the routing infrastructure. Students can measure, understand their performance and what paths they take to different destinations on the internet. They can also look at, if students are in diverse enough locations, you can study interesting properties like the asymmetry of BGP routing, or conducting longitudinal studies and sort of looking at what paths students take over time, or what CDN servers they encounter, all of these things. And then finally, getting to like resource allocation and understanding what happens when you have conflicting flows or conflicting programs on a computer. And so here students might run simulations to slow down things, change browser settings, or getting help from family, friends, roommates to help conduct experiments and understand how their traffic reacts to competing flows. And then we also want to generally make students better and more informed citizens of the network and the world. And so to do that, we want to engage students in public policy questions surrounding the internet, especially things that are relevant now in the age of COVID. Dan talked earlier about integrating computing and the news into courses. And so we want students to reckon with, for example, the fact that there are many students who don't have proper internet access. As instructors, that's a difficult part of the course, and how do we reach out to students? But for students, maybe they also don't realize these challenges. And so we think it's important for students to recognize that even their own classmates might have issues connecting to the internet, and discuss the ramifications of that. And we also want to have students understand past world events and how they have affected the internet, natural disasters, wars, political uprisings, and then also talking about future events like climate change. So, how does the world deal with thousands of miles of new undersea cables that weren't designed to work underwater? Probably not so well. Now, there's many challenges that go into designing a curriculum like this that we have to consider. So students have many different computers they're using, different hardware, different OSs, they're in different locations. So how do you get them to collaborate together? There's also the issue of, well, if you're showing students that, hey, you're in a location that doesn't have so great internet, and you're constantly reminding them that they have issues with their connectivity, that could discourage students from participating in the course. And so in our white paper, we discuss a bunch of ideas of how to try and help students, allow them to be anonymous, allow them to opt in to sharing measurements if they want, so that they don't feel obligated to do so, but sort of making it part of the general discourse of the class, we think is important. And then there's other challenges like, certain topics we can't discuss, like SDN and network management, and how do you grade this? How do you make a full curriculum out of it, et cetera. And then finally, we think there's aspects of this, other benefits that student measurements could provide. For example, having a sort of a global data set where students can contribute measurements to compare results across courses and sort of understanding what the state of the internet looks like, we think would be really cool. And then we also have ideas on how this user-centric networking, these measurements might even last after lockdowns are returning, and as Jim said, sort of entering this hybrid state of networking education. So we talk about that a lot in our white paper, and that's all. Thanks to our commenters for their feedback.
Great, thanks. So Larry, I'll kick it to you to start the discussion.
Yeah, thanks. So, man, this has been a great set of presentations, and I'm in the privileged position of getting to ask the first question. There's some coming in, get your questions on Slack, but listening to Keith's talk and all the questions he asked about how you put, what goes in the class, what doesn't, how do you teach? It's just, I think we all go through that every time we put together our syllabus, and you absolutely go through it every time you upgrade a textbook. And I mean, just an example of that is I struggle every time as to how much old stuff to take out when the history of how we did it, and then maybe we got it wrong, and then we figured that out, and then we got it right, is a value in itself. So how do you deal with that? So I'd just like to start by asking the other panelists, Keith, you can jump in as well, but how do you answer the questions for yourself and your students and your textbooks and so on? How do you answer those kinds of questions? And Jim, I got to go to you first because I know you've dealt with this scoping problem as much as anyone here.
Sure. Let me just say how much I appreciated all the talks, and Ross, the other Ross, Keith Ross, and I have these discussions all the time. We committed at the very beginning with our first edition that we were not going to write a 1,500-page textbook, and we're going to put something that's mostly digestible. So we always, if new things go in, we started a whole new separation between the control and the data plane, a lot more on wireless. We had to take things out, and so we took out things on some on network management, and so you do have to make those trade-offs. You said something, Larry, yesterday about students should be interested in history. That's always been my point of view. My co-author says absolutely not, and so since we argue about these things, he's usually the one who's better about taking things out, like there's nothing in multicast anymore. So you do have to take things out, and this gets to Keith's question about, and when it was in his white paper, you just can't keep adding more and more in because students get overloaded. And I'll give you a personal example. When I first started putting my lectures online, I told students, oh, look, now you have all the material on all my lectures from last semester online. So we're going to do active learning in the classroom. We're going to dive down deep. What do you think of it? And I told them, we're going to do that in the fall for new students. So I want you to put yourself in the new students' shoes. And 80% of the students said that's a terrible idea because they don't have the time. And if what they really want to live and exist all the time was networking, it would be a great class, but they take 3 other computer science classes and they have lives outside of school. So we have to keep that set of material small. And I think it's individually how we choose what goes in there, but adding more and making it harder and making it deeper, that was one of the words of wisdom in Keith and Nick's paper. We've got to be very careful about that because we can't just say, oh, it's so important and there's more and more to do, because everybody says that about their discipline, right? So.
Yeah, at some point it becomes commodity and you just go buy it at Best Buy and then maybe you stop talking about it in a networking class. I don't know. Anyone else want to jump in on that one?
So I guess I would say a couple of things here. So one of them is that at our school, we also teach in quarters, is the database community among the faculty actually split their course into 2. So there's essentially a course that's pretty similar in many ways to the philosophy that Jen and Ross's class had, which is, okay, you're going to give somebody an introduction. What is this? To try to tell people what they need to know about networking, but not try to be an implementation-oriented class. It's let's go explore it. Let's figure out how this relates to you. How does it relate to everything else? You can think of this as like what everybody should take, and actually that class gets taken by everyone. And it's early. It can be taken earlier in the curriculum because it has less technical material, the less implementation oriented. And then there is a separate class, which is let's go build databases from scratch, and let's just make a system let's give you the kind of implementation experience. And it just seems like there may well be this like ability to not try to squeeze both of those things into the same class, may be actually a way forward.
Thanks. Anyone else?
I'll just add that at UMass we did something similar.
Yeah, the user of versus the builder of is, I mean, I think operating systems has done something very similar.
So the other thing I was going to mention about, and this is something that Keith raised, which is this question about whether we do specifications for homework assignments or do we leave them open-ended. And so like be interesting to hear what other people say about this. But we've in the distributed systems class, which again is very technical. It's actually an implementation-oriented class, but we have gone entirely towards just specifications. Like it's a problem if our specification is not precise, right? So we are trying to say this is precisely what you need to implement, and but of course, like this is the functionality that you need to implement, as opposed to this is how you're supposed to implement them. Now it turns out for distributed systems, that's complicated enough. It's like, oh, okay, go build a system that actually delivers packets from here to here. Or in distributed systems, like build something that's linearizable or something like that. I think I've seen, and again, this is like just something that seems pretty effective, is that if you want something that's open-ended, the better way to do that is to have a really open-ended part of the assignment. So I have a colleague who teaches operating systems, and the last assignment is basically pick your own assignment to go do. And just like, if it's totally open-ended, then that can work pretty well. But if you're going to give every student an assignment and the same assignment, then you really, I think the students deserve to say, this is the specification. We have a test case for it that will tell you whether you've gotten it or not. And that we ought to owe that to every student that we're teaching. It's like, this is the pass, and this is all you needed to do. You should be able to tell whether or not you've done the job.
Anyone else want to jump in? Keith, you're welcome to jump back into it.
Yeah, I'm thinking about this, Tom. We have a very detailed and nitpicky test suite, but I'm thinking back to my own undergraduate experience, and the best classes I ever took were like, it was a physics class, was one of the best, and we would get the seemingly impossible assignment, and you did have to show up and express your confusion and get coaching. And I always felt that this kind of one-on-one model was how learning really happened, trying to sort of meet students where they are. And I've always been, I don't know, it feels like dropping them, with like 500 pages of specification like you'd give if you were outsourcing the project. I feel like.
Yeah, I mean, maybe it's to some extent also related to the difference between these and topic area, right? So if I'm going to do a database, like, oh, okay, I'm going to say here, go implement SQL, or this is the language to go support, and this is the property of it, and I will give you some kind of implementation-oriented question that requires me to be able to implement transactions correctly. It doesn't say anything about how I format those transactions or whatever. So it may be different in the kind of networking space where it's like, oh, okay, you have to implement this protocol. So it makes it more difficult.
I think
so the point that the personal experience Keith just raises actually connects the dots between this discussion and the pedagogy. So I would think specification where it would be better in a as you scale, and the more you have to do one-on-one, that obviously harder to scale.
So
I think that's true too.
Okay, I see Jim's face, so I'll go.
I was going to say also that I thought Keith's comment connected to pedagogy, but in a very different way than you just mentioned, Larry. And that is that I think that, we'd all probably die to have students like Keith in our classes, right? But they're not all going to be professors of networking at Stanford, right? And so, I'd mentioned earlier about this notion about contextualizing and personalizing to the students. And I think we do have to think about where are the students at, right? And what is it that's going to work for them? And as much as, I remember doing quantum mechanics assignments and not going to bed at night and how much I love that, I saw students who flailed and just couldn't do that or didn't want to do that, right? And so I think we have to be very careful not to project ourselves always onto our students. I mean, maybe some of them are like us, but some of them aren't.
The vast majority probably are not.
That's probably fair.
I mean, we all intuitively are in the business of trying to reproduce faculty at universities, which is probably not the right model.
I'd like to add something about the basics. So it has to do with the question of the slides from Ross. How much the basics and the specification kind of thing. This is an open issue because I do think you need the basics to understand how things work.
Yeah, Ross, it'd be good to hear your reaction to all of this.
Yeah, absolutely. I mean, we started out with like a clean slate approach and to see how far you can get with pure internet measurements and what can students understand. In terms of, building this out into a full curriculum, I think, yes, there needs to be some discussion of the basics at the beginning. They need to have a pretty general sense of sort of how layering works. Maybe Jen can touch on this a bit, but at Princeton's networking course, we sort of take a similar approach where layering is sort of quickly introduced in the beginning, and then sort of the rest of the course is devoted to design patterns and understanding like different choices for the networking infrastructure and how it fits into the layers, but how it also might touch across multiple layers. So there's definitely, I think, value in looking at designs more broadly than just going layer by layer.
Right, and I might echo what Tom said earlier, that there may be, that very user-driven, curiosity-driven may work really well in one circumstance. So maybe for maybe a less, I don't want to say less non-technical, but for people who want the broader perspective, they want to look at policy and net neutrality, and you want to sort of be able to motivate them that way, versus the people who want to get sort of down into the guts of the systems.
Yeah, absolutely. I mean, it's definitely hard to tailor a course for everybody. I've been sort of thinking that getting CS students more interested in learning about ethics and the consequences of their work is sort of generally important, and trying to learn how to integrate that into different aspects of CS, I think, is a worthy discussion.
Should we organize, let's say, since we, as a community, having pieces of topics, and that would, let's say, if you take the student take ABC, so you are more oriented, so you get the class and you're more oriented to that. But if you take BCD, you get that. As a community, it can be done. It's difficult to do that alone at the university, but and then diverse the students, so let them choose what it's more interested for one or for the other, but they both have a broad idea what's going on. That's a question.
I think that's absolutely doable, Edmundo. I think the question is where do you get the materials to do that? And I think, again, that's a place to look online, right? Because it's not like everybody's going to take a systems approach to networking, or a top-down, or a bottom-up, or a middle-out, or a user-driven, that people are going to want to do it different ways. They're going to want to contextualize it for their students. And so if you have materials online, if there are materials online, then I think what you do is you pull different pieces from different places. I mean, I'd love to, be able to get some online material on net neutrality, for example, or something that's, right now on security from a voting perspective, right? That's what's going to really draw the students in.
Yeah, that's a great point. And I'm just thinking we're focused on how constrained our one course is, but curriculums are equally constrained. So you can't have you don't get arbitrarily many variations of the networking class, but across all universities, perhaps you do, and it gets sliced and diced differently. And I think that's kind of what we were talking about with the community resources a little bit yesterday. Build your own class from the combination if we only had that collateral.
Right.
So perhaps a hot take or whatever, but it's hard for me to see that there's a huge amount of evidence that the variety of different ways that we teach classes is actually effective for students. Like that there really is a big difference, like a really significant difference by my teaching it this way and somebody else teaching it that way, or that our students are that much different from each other that we have to have these differences. I mean, I know we do. It's partly like we do it because that gives us some creativity control or whatever. I think primarily that difference is for us and not necessarily really a huge benefit for students.
Oh, you just asked the question of the session here. Now, how do we answer it? Of course we do it for ourselves.
Yes.
So, you know, I will, let's see, we're recording this, so I'm not sure I want to say it. But what I could say was, I think you're right, Tom, it doesn't really matter that much whether we teach it bottom up or top down or systems or inside out. But what I do think really is a difference is that different faculty at different schools have different kinds of students in their classes, and those students have different needs. And that's where the personalization that an instructor does makes a really big difference.
So sorry, I do apologize for interrupting, but but this actually I think is exactly right. I mean, I think it's in some ways we underestimate the notion that what universities primarily do is to accumulate a group of people together who have the same background so that we can teach them essentially the same way. And that's a much more efficient thing to do than if we had students who had a really like hugely diverse background and we have to figure out, okay, this is the pace at which students learn, or this. I think what we often fall into a trap of is thinking, okay, the students who don't have the same background or whatever aren't able to learn the material that we can teach them. I don't think that's true. I think there's a lot of evidence that if you do actually, you know, collect a group of people who have the same background and essentially the same pace of learning, then you can be effective at getting them to the same place that the other students are. But it's certainly a lot more efficient if you have students who have essentially are similar in some way.
Well, and again, I'll come back to you know, the issue that Keith brought up, that even among students who have similar backgrounds, not all of them have the same amount of intense interest. And so not all of them are going to want to get into the depth of debugging a SIG fault or something like that, right? And so we do have to be careful to just, even among a group of pretty homogeneous students, remember that there's different levels of interest.
So I wanted to,
Okay, go ahead.
okay, so back to Tom, sorry. So I thought where you were going to go, Tom, is that as you scale is going to drive you to homogeneity. And that maybe that's not what you're arguing?
No, I think that's true. I mean, I think that there's little evidence, little concrete evidence. I mean, maybe the anecdotal evidence that, hey, the way that I teach this class is so much better than the way that somebody else teaches some class, that's, you know, a significant difference or something in that. I think there is a bit of evidence that there was some experimental evidence that if you look at like income levels of students who go to R1 schools versus income levels that go for students who go to R2s or teaching colleges, that those are really different even for people who get CS degrees or for engineering degrees. There was a big study done in Texas along these lines. And so it does seem like there is something that we are actually offering students by teaching them what we're teaching them. I'm not trying to disagree on that part, but it seems it doesn't really feel right to say, you know, exactly how you would go about doing this. And maybe standardization would help us quite a bit. Standardization works really well at K-12. It's like, oh, Jim is about to disagree. So go ahead, you can disagree.
No, go ahead. Then I'll disagree.
Well, I was pretty much done, so that's fine. You know, that maybe by standardization we have more of an ability to share than we would otherwise, and more of an ability to scale, which I think is what Larry was saying.
I would advocate. I think heterogeneous is good. It's good to have also has its advantage. I understand the problems, but it has advantage as well. And if you promote interaction of the student, if you have the ability to do that, I think it's beneficial for everyone and works well. So I like when the things are mixed.
Yeah.
So I have to tell the story of when I took networking as a grad student. And I ended up obviously loving the discipline despite the class. We spent the entire semester learning different ways to implement CRC in hardware. And that was my, I mean, which is to the point, the class is taught according to what the instructor's interests are. And that's somewhat inevitable, but obviously we now have an opportunity to share more and benefit from other stuff that's online. That probably didn't help move the discussion along, but I couldn't help but think of specialized versions of the class. So let's see, we have a few, well, actually we're getting pretty close to the end of the time here. So any other final comments?
You know, I just wanted to make one comment again about the issue of standardization or homogeneity, right? And I think that, you know, we had a long discussion yesterday about textbooks. I think textbooks, another word might be generic, right? So, you know, a textbook, if it's going to be adopted by a large number of people, it's by definition generic, right? It's sort of one take. And I think when that's sort of necessary to achieve scale, but I think that, again, maybe I'm just repeating myself, that the ability to personalize and choose material that fits the students who are in the class is what's the critical thing. And, you know, it may be different from UMass to UMaryland, even though in many ways, I suppose they're sort of equivalent schools. I still think that the students who make up that class are going to have different interests. And so you're going to want to personalize it some. If we don't do that, well, I just think we have to.
And on that note, Jen, do you have any other wrap-up comments?
No, this has been a really great discussion, and the discussion on the Slack has been great as well. So I think we should let our organizers, Jim and Matt, conclude.
Yep, I agree. Thanks. Thanks, everybody. It's great panel.
Thank you for organizing this.
Great.
Thank you.
Thanks.
Okay, so Matt, I see you're online. We should wrap up. Actually, I think maybe Matt and I didn't quite do our homework to figure out how we're going to wrap this up. Maybe I'll start off simply by saying, first of all, we want to thank everybody. You know, the series, this is the fourth in the series of the SIGCOMM Education Workshops, and they've just generally happened because people are interested, and you know, not because they happen every year and not because we necessarily get credit or whatever for them, but we do that because we're part of a community that cares about this. And it seemed like a good time to be having a workshop. And I'll tell you, the response has really been phenomenal. We've had just a tremendous number of people participating, and it's summertime, it's vacation time, and yet we're able to put something together really quickly. And so many hands went into making this. So thank you again to, first of all, to the sponsors, to SIGCOMM, and thanks to AMLS, who helped us really so well navigating with Zoom. Thanks to the session chairs, all the people who wrote white papers, and all the people who've been participating in this. That you know, Matt suggested we do Slack, and I'm like, oh, you know, he's a young guy, I'm an old guy. I'm like, Slack, okay, sure, if you want. But wow, that's just been phenomenal. So now I'm really a Slack convert, and there's just been such great conversation there, and it's great. It's gonna persist. And so there's been a lot of rich material and a lot of rich discussion. We're hoping to be able to synthesize it again through these two Google Docs. So please contribute to those, and continue to contribute on the Slack. Let me say also that we are going to be posting, as we said, the videos from all of the sessions. We're going to edit them down a little bit so that they're individual sessions, and then we'll also include the evening conversations that we've had as well, and we'll post those on the website. So if you come 2 weeks later and think, oh, I heard this really good idea that Keith said, you know right where you can go to get that again. So with that, I think this website will continue to be a resource, and my sense is this community as a whole really wants to get together and create more resources and make sure we share those resources, whether they're, you know, programs and software, or whether they're teaching tips and how to do pedagogy. So let me turn things over to Matt.
Yeah, I just want to echo what Jim said. It's been really great hearing all the ideas. I learned a lot. Really enjoyed interacting with everybody, and it'd be great to keep in touch. We're gonna probably be sending out a poll later today, just kind of asking for any additional feedback y'all have. And there's the Google Docs we can keep collaborating on. One thing that Steve mentioned on the Slack was this CCR now has this education series. So if you're interested in publishing educational articles in the future, you can submit to CCR, and there's actually an educational track. So it'd be wonderful to have submissions there as well. But yeah, that's great.
And Matt, do you want to say just a word about maybe it's not public yet. I've seen the draft of the revamped education SIGCOMM Education website.
Oh, right. Yeah, we've been working on a revamped education website. If you go to education.sigcomm.org, there's a new website there. We're starting to put together some material on resources, for example. There is a resource page. It's quite bare bones right now, but we'll probably be adding stuff in from the Google Docs to improve that, and getting some better infrastructure there too, of course. There's also an advice page. We tried to collate there's so many great advice articles online that people have written, advice for grad school, advice for new faculty, and so we tried to put together a page on that as well. In some other sources. So if you go to education.sigcomm.org, there's some various resources there. And you can email me if you have ideas for other resources. There's like a contact email address on there. So that would be very helpful as well.
Okay, great. Well, I think with that, golly, my clock says exactly 12 noon. So we're right on time. Thank you again to everybody. And I'm sure we will all continue to see each other sort of around online and maybe even in person someday again. Okay. Bye-bye.
Thanks. Bye-bye.